us.
Yeah, we don't know what's going on. Dave Weiss, welcome. It's great to have you. Ross is here as well. The other Spacebuster people don't know about because we've been doing all the germ movies for so long. But I'm really excited to have you, and so is Ross, because we have a lot of new subs ourselves because of the nature of our films. And a lot of people come on to me and say, stick with the germs, Steve. Flat Earth is a psyop. Mark Passio told me so, and I wanted to really get you on because we're in a new paradigm where everything is being laid bare. Every science, theoretical science, the veil is lifted, as they say, and people are starting to see that everything we think is reality is not. And so for the people who are watching this might be new information to you, or you've not run across this. I wanted to have you on to give your presentation and show people things they maybe haven't seen and let them make up their mind. And I've seen your recent presentations with my friend Jeremy Nell, Germ Warfare, and David Wolf, and it was brilliant. So thanks for coming on. Yeah, I'm looking forward to this.
Hey, thanks for having me. I'm as I told you before, I'm in Mexico for a little while, and I've rethought this. And I think the idea of the Earth being a flat plane is absolutely ridiculous. Look at this. This is the dumbest thing I've ever seen. And, all the science tells us that we're on a spinning globe, and nothing tells us that it's flat. And, how could everybody in the world be lying? And what difference does it make anyway? With all the stuff going on, with all the good work that you guys are doing, why are you focusing on this stupid topic?
Yeah, exactly. And it's important. What would you say to people who say, I hear that a lot, who cares? Right? What would you say to people? What does it matter?
That is so there's a process everybody goes through. And when you first hear about flat Earth, you think it's stupid, like we all did. And then only when you look do you realize, wow, the psyop is huge. And then as all of the proofs that you think that the Earth is a globe get ripped out from underneath you. Boats over the horizon explain, sunsets explain, seasons prove the Earth is flat, right? And then you throw up your hands. An intelligent person throws up their hands and goes, why does it matter? And then they also program to say, they can't even keep a blowjob a secret in the White House. How could they keep this a secret? And all of that is a psyop. But when you do throw up your hands, the why to lie is your last defense on holding on to your globe reality, everything you've based your life upon. And then when you finally look, the big thing is, I got to go to work on Monday. What difference does it make? I still have to go to work on Monday. Everybody says that. I said that. I don't have to go to work on Monday. Something changed in my life, this is, and the reason I push this so hard is this is the key to separating ourselves from the global elite control matrix. I say the heliocentric ball is a matrix. It's a prison for your mind. And when you release yourself from it, it literally frees your spirit. It opens you up to creation and to your true potential. So this is the most important topic of our time. Now, you guys do the best work ever on the boogeyman, and it's amazing, and I often get, Dave, with all this going on, why are you focusing on flat Earth? Because the flat Earth has people so lost that they can't see through the boogeyman. They think the boogeyman's real, right? And so this is the foundation of your worldview. So if you believe that you're on a lumpy rock, surrounded by curved spherical water, surrounded by curved air, adjacent to a void, scientifically impossible, flying through an infinite universe where, asteroids can take us out, we're running out of resources, we're overpopulated, the boogeyman's going to get you, all of this stuff, you'll believe anything. You'll believe anything, right? So until you have your feet planted on the ground, excuse me, planted on the ground, and know where you are, who you are, what you are, you're kind of powerless. How about that?
Yeah, exactly. And you're living in a fiction, or the Matrix, as you say. It's Harry Potter, and then, like you say, once you're in a complete fiction, then the little sub fictions are very easy to con people with, because if you don't even know where you are in the first place, you have no idea how to navigate through the little sub traps and fictions within this fiction.
What you find is the people that fight against you the hardest, other than the anti-flat earth, paid or possessed people, are people that have no idea about their own model and a wrong idea of the flat earth model. They think this is flat earth because this is what Google fed them.
Yeah.
How many times have you heard, what are we, the only pancake planet? Are all the planets pancakes, right? These are pre-programmed propaganda that Google serves to your brain, and they become part of your, these are the reasons that we live on a ball. This is where we're at. So no flat earther thinks this is that. Only people that think flat earthers, you think we're a pancake, think this. Does that make sense?
Yeah. Well, it's like when you Google flat earth and you get the Flat Earth Society and it says we have members all around the globe. That's clearly there to make people go, all right, these people are crackpots. And this does sound crazy. It did to me because Ross grew up, he was the space guy. Like Ross grew up total NASA fanboy. I was more like dinosaurs and Dungeons and Dragons, So when I've heard about flat earth, I got taken in by the Nibiru crap, the 2012. I came to Ross very cautious and I was like, dude, about space. What do you think of this? Right, Ross? And even you took a while to.
Yeah, well, I mean, when you first told me, I mean, I hadn't even thought about it. I hadn't even considered the fact that the world was anything but a ball. Yeah. But until you said something to me, that got me thinking. Yeah. And because we were both in the stages of like waking up, as they say, it started making sense to me, and I started looking into it. And I must admit, within 2 weeks, I was sold, absolutely sold. And as Steve said, I was the biggest NASA fanboy of all time. I had models. I used to speak to my dad for hours on end about, space time and everything. And so it was a real shock for me. But it came as a real welcome shock because all of a sudden things started making sense. Everything that I'd looked at over the past few years was starting to make sense. Like the flight times or the flight routes and all of that stuff that we look into. Everything started. All the dots started connecting. And
the ether, there's also, this brings in the ether, free energy. I mean,
that came afterwards. Yeah, it branches out into many different things.
Yeah. And Dave, we had a couple questions. So Ross made a list of the 4 most common questions that we get asked or questioned about by people who say, well, what about this? What about that? So if maybe we could just start with that, have Ross ask you a question and you tell us your take on that. Would
Absolutely.
That be all right?
Yeah, feel free.
Okay.
Sure. Right. Well, I mean, as you know, Dave. Oh, by the way, nice to meet you.
Hey, nice.
Yeah, it's a pleasure.
I listen to you all the time. Your work is the best.
Yeah, well, I mean, same here, mate. We've been watching you for years, and we've seen your presentations, and I know that you know the answers to this. So do we. So do most of our listeners as well. But as Steve said, we got a whole bunch of new listeners now, so I think it'd be a good idea to go back on some of these things.
100%. One thing that flat earthers know for sure is that we don't know some things. Exactly. Globers think they know everything, but they have no idea why. When you go to a glober, like, what's your number one proof that the Earth is a globe? The best thing they could say is southern star rotation. So they're looking up at lights in the sky that aren't even what they are, provably not what they say they are, and they think that that's proving the shape of the ground. It's they've got nothing, but they think they have everything. It's amazing. And by the way, I was that person. I banned people. I've heard it a million times, right? For even suggesting flat Earth. You're too stupid to listen to my podcast. You can no longer comment. So, all right, hit me.
Right. Well, I mean, I went through the comment section in a few of our videos as well. I'm trying to come up with the ones that we get mostly. And I think number one is either the Southern Cross or the tides and the moon. So, I mean, whatever. Yeah, start with the tides.
Yeah. So,
I mean, as you said, I've done a one on the tides as well. So yeah, let's hear your take on it, Dave.
Yeah, so tides, everyone thinks that the tides are gravitationally locked to the moon, which makes no sense. So, if you look at the official story for the tides, I'm trying to find an image that from our good old friend Neil. Where is it? Oh yeah, here we go. We'll go with this one. So they tell us, we have a high tide bulge because the moon is pulling the water away from the earth. Right now, if you think about it, if the moon is pulling the center of the ocean out, wouldn't it be low tide? Wouldn't it like pull the water away? I don't know. Maybe skip that. But this is the official story. The moon pulls the water away, but at the same time, 12 hours away, there's a high tide on the other side of the earth. You know what the official explanation for that is? Did you guys ever hear what Neil says? He says that the moon is pulling the earth away from the water because
well, I mean, if you go by their mass attracts mass, then I mean, surely the earth is bigger than the moon.
Yeah. I mean, they talk about wanting your cake and eat it too, or whatever the hell that means. They just say nonsense, and people are like, well, I can't, it's beyond what I can think, because I wasn't taught to think. I was taught to memorize. Therefore, it'll be easier for me to memorize what they just said than actually explain it. Okay.
I mean, my favorite one is when you're drinking a cup of coffee and the full moon's overhead, or a beverage. Why is your water not being pulled up by the moon or in your back pond? Like, it's ridiculous to think it would pull the earth water and not your coffee cup when it's overhead.
Yeah.
Why wouldn't it affect a smaller mass of water?
And why wouldn't it pull the air up away from the earth? Right? If it can pull water up, why doesn't it pull the air up? And people say, well, gravity, well, how do clouds float in the sky with trillions of tons of water, billions of tons of water? Okay. And the global argument is, well, the water molecules are all separate and they're very small. Well, I don't care how small a water molecule is. It's heavier than an air molecule, right? It's heavier.
Yes, so it could actually pull the air up as well. Yeah.
Yeah. So that whole gravity tide thing. So I'm trying to find my little tide chart here. There are tidal nodes all over the world, and these tidal nodes are where there's no tide at all, right? And then the high tides and low tides circle around these tidal nodes, and there's zero correlation to the moon, right? Yeah, when there's a full moon, there's some higher tides. Well, I think that's because the moon is powered up when it's full, right? And it has something to do with the electromagnetic forces on Earth. But if you think about it, why would there be a bigger high tide when there's a full moon than when there's a new moon? The moon's still there, right? And a new moon, it's there. It just doesn't have sunlight on it. So why would there be any difference in the tide at a full moon, right? I mean, in the heliocentric model, that's the story. I think it's exactly, all, yeah. So when you lay when you actually lay the tidal nodes over the quadrupole magnetic map of the Earth, they kind of line up there. So there's a lot there. I'm on the app, the Flat Earth Sun, Moon, and Zodiac Clock app, which I assume you guys have. There's a tides button which has a bunch of videos on tides that help you make up your mind for yourself.
Great, yeah. I mean, as you know, I come from England, and there's places in England where, in the space of 5 or 6 miles, there is harbors that have no tide, and then 5 miles down the coast, there's one that has an 18-foot tide, which makes no sense whatsoever. So,
right,
yeah, right. Well, next one, Southern Cross. I bet you got to you speak about this one a lot, don't you, Dave? It's one of the main ones that we get.
Well, the Southern Cross, what is the exact question? That's what Southern Cross. Why can't you see it in the north?
Why can't you see it in the north? Yeah.
Yeah. So the idea that you can see stars far away is because you believe light travels forever and the stars are infinitely far away. So, how come you can't see it from flat Earth? And the truth is, the stars are very small. They're very close to us here on Earth. And as you walk away, as you go away from a star that, let's say you're at the North Pole, as you go farther away, it gets lower in the sky, just like a street light. If you're standing under a street light, that's your zenith star, North Star, whatever you want it to be. And as you walk away, it gets lower and lower. So if you're going on a road which has a bunch of street lights, a nice straight road, and stand under one, and that road, that street light is directly above your head, but look at the one a half mile down the road. It's merging with the street, right? It merges with the street. And then think about one that's a mile farther. You can't see it, okay? But this is just a terrestrial, and I'll call this light a terrestrial light because it's pretty darn close to the Earth. A celestial light is above the atmosphere or the atmos, okay? And that atmos, the air, when you look, let's say you look up, let's say the air is, the air column, we'll call it, 15 miles, whatever, 5 miles high, whatever it is, it's okay. And then you look at it 20 miles away, that entire air column is compressed into where the sky meets the land. And that is opaque. People have a hard time dealing with that. That becomes opaque. And anything that's terrestrial, like a street light or a boat or a plane or a mountain or city skyline, is compressed in there. But you can zoom in and see it again by increasing its angular size. Anything above that light, okay, anything above the atmos plane is going beyond it and disappears beyond it, and you just can't see it. Even if you had the Hubble telescope, which isn't real, but if you had a telescope super powerful, you can't zoom in through opaqueness. You with me?
Yeah, completely. It's just a perspective thing and a distance thing. Even if a blimp flew over you, which is huge, there would come a point fairly close where you wouldn't see the blimp just because it's merged under the horizon line of where visual perspective meets.
Here's an orthographic side view. No one ever sees a side view unless someone's taking a picture, but you still never see this. This is how your brain is thinking the world works, but this is not how we see, right? So here's our a celestial object. Here's our atmosphere, and here's some terrestrial objects. And then when we go to a normal view, everything merges into the horizon, right? And if we look, these are some little waves I just put in here. My graphics are phenomenal, aren't they? And everything kind of merges into this, right? And this is the person's point of view. And as the atmosphere starts condensing, boom, it's completely blocked. So this boat, it can still be seen if you increase the angular size, but the sun is blocked behind what this guy's seeing. It's literally just becomes opaque, right? Can't see the sun because the sun is going beyond it, behind it. But if somebody was standing underneath the sun, it would be way above the clouds. It's just all perspective.
Absolutely.
This is like those weird videos where you see it looks like the sun is sitting in the clouds and there's clouds behind it. But this is what you're talking about, isn't it?
Well, that's a whole nother thing. I'll show you that in 1 second. So here's an observation, and I actually just recreated this from a photo I took. And you're on a boat, and you can see this building. Now, this building is 10 miles away from this shoreline. So you see this building going here. Now, if this boat went away from this building 20 miles on a globe, what should happen to this building? It should disappear. It should start disappearing more and more. But what happens is as the boat moves away, the building gets taller. It gets smaller, but it gets taller. You can see more of it. Okay. On a globe, that should not happen. As you go 20 miles away, that building should drop away. But on a flat plane, your angle, if you drew a line from this boat to the top of the trees, is a much more lower angle, right? I'm feeling a little transparent today here. Okay. And so this observation, I need to video it and then really put it together. It absolutely proves that we are on a level plane. And then you were talking about the sun and the clouds. So is the sun actually in the clouds? And the answer I've been giving lately is yes and no. Okay. I don't believe this is the actual sun. This is the sun that we see. The real source sun, in my opinion, is within or above what we call the firmament. Okay. And depending on atmospheric conditions, your position, and everything, the sun manifests in a place for you. Have you guys seen videos of planes flying through the sun?
I have some, yeah.
Yeah. And when it comes out, it leaves like a trail, like some plasma behind it. You've seen that, yes?
Yep.
Yeah. So, saying that the plane is just flying in front of the sun and you can't see it because the sun is so bright. I used to think, okay, that's a viable explanation. But I think that your experience of seeing that plane, you are seeing it go through the sun that's in the position that you're seeing it in. I mean,
from your perspective,
your perspective, but somebody that was in another position doesn't even see the sun go in front of the plane go in front of the sun, or it's below it or above it or whatever.
Exactly. Yeah.
And so, you know what that tells me? That tells me that this reality is beyond what our minds can actually explain. So
that's
again,
probably why we're having such a hard time explaining it.
Yeah. So seeing a plane go through the sun, does that prove the Earth is flat? No. It proves that we don't know what we're looking at in the sky. I mean, unless you can touch it and measure it, you can't make any solid claims. Crow, 777 radio always says the only accurate thing you can say about the sun, moon, and stars in the sky is that they're lights. That's all we can accurately say. 100%. They're lights.
Yeah.
Because we can see them. You can't make any other claims about them. I mean, we can speculate, we can look at a lot of evidences, but until we can go there and measure, it's off the table.
One of the interesting things, that picture you have now, if you can pause that.
Yeah.
That phenomenon, that phenomenon where the light is coming off the water right at you.
Yeah.
The sunlight is reflecting straight at you. Well, I've seen experiments done where people have taken a piece of cardboard and a light, and as soon as they bend the cardboard, that light no longer comes straight at you. The light doesn't hug the curve, but it does on a flat piece of cardboard. You know what I'm saying? You can recreate that light trail. And
I have no idea what you're talking about. Can you explain it a little better?
If it's a globe, you wouldn't see that line.
I'm kidding.
Where is it? The super flat ocean there.
I'm kidding. I'm showing you one of the best examples of
you have it, yeah.
Right, okay.
So here we have a light in the background, and we bend it, and it's a point, and then we lay it flat. And let me, which one do you see? Whoops. Yeah. So it's not a ball, because that's what we would see if it was a ball.
Yeah.
This is what we see in reality. Curved Earth, flat Earth. Which one matches reality?
Exactly. Another thing, actually, if you've got two people standing on the seashore and they're both looking at the setting sun, they will both see that reflection, but you won't see the other person's reflection. It's a personal thing.
So are you saying that we have a personal we have a personal relationship with the sun that walks on the water to our feet?
Almost, because that person that's standing 10 feet away from you, looking at the sun, will say that I can see that reflection. It's coming right to my feet. But why can't you see it? You can only see your own. You can't see the other person. So it's a perspective thing from your own perspective.
Yeah. And a lot of people have a real hard time. Have a hard time with that one.
Yeah.
And it's because they don't understand how we see, right? When you say that the horizon rises up to your eye level, the people like, and the sky ramps down. People don't understand what that means. Okay, they don't understand. As I'm talking, I'm trying to find an actual graphic that I have to show you, but stall for me for a minute. Say something else, and I'll find it.
Yeah, you have a look for it. Another thing for me with the light that is proofed. A lot of people say, well, the sun's 93 million miles away. Yet when you see its rays coming through the clouds, is that called crepuscular waves? You know, that it fans out triangular, and it should come straight down if it's 93 million miles away. It has to be close, whatever it is. It cannot be that far, or else the lights wouldn't be shining down in a triangle.
Exactly. It's actually simple geometry to triangulate, the position.
Well,
which
people
is what they used to do for years with sextants when traveling, you know.
People, say, oh, Aristophanes proved it with his sticks and shadows. We have the corpuscular rays, but on a flat Earth with a local sun, we have our shadow, we have no shadow. You can do the math. Math explains anything you want it to explain. But if the variables are wrong, then then the entire thing is wrong. So the one I wanted to show you, which I just found and lost again, is this. So let's look at these lines here. So we have a yellow, an orange, and a red line. Now let's do some math. Are they the same length? They appear to be pretty much the same length. Wouldn't you agree?
Yeah, they look like
it. And the yellow one you would say is the highest one, and the red one is the lowest one. Now, if we look at the red one, it's compared to the orange. It seems compared to the yellow's distance from the orange one, it seems maybe twice as far. Just rounding off. So we can do height of orange plus X equals height of yellow. And then we can go height of red minus 2X equals red, right? We can complicate these equations and complicate them more and more, right? So let me flip this. So now we say, which line is the longest line? And you might say, which one would you guys say is the longest line?
Red to me, yeah,
okay,
red.
The red one. So the red one's the longest one, and we can make equations. 3x or 3y, y for yellow, equals red, and 1.9 orange equals red, and then we can just go on and on from there. But let's look what we're really looking at. So this bush here is about 5 feet above this deck. This is the edge of the deck, which is about 10 feet above the ocean, which is down here, right? There's a pool here. There's an infinity edge, drops down to the ocean. And this is sea level. So this line is 15 feet higher than this line. This line is 5 feet higher than this line. So this is the highest line. This is the lowest line. This is measuring probably a couple of miles. This is measuring maybe 15, 20 feet. And this is measuring about 6 feet. So this is the shortest one. And this is the longest one. All right.
Exactly. Yeah.
So math, when you're looking at something, you could apply math to it, but it doesn't describe reality.
I think that is probably what one of our main problems is at the moment with science and basically scientism, is that you can turn anything into an equation and get it to do anything you want it to do.
This is the lowest line, and this is the highest line. That's how we see. So once you understand that, the ball disappears, right? Absolutely, because think about this. If we lived on a ball, this is just getting lower and lower and lower. Why the heck is it rising up in our perception?
Yeah. Exactly. I get you. In fact, I did one of my first videos, I think it was, is that if you're looking at that horizon there, what they say is that I think if you're 6 inches off the ground, then the horizon should be round about 3 miles away, something like that.
Yeah, 3 miles.
Yeah. So let's just say you're standing 6 foot off the ground or eye level. Should you not be able to see a curve going left to right as well.
I don't
If you
think
say
so.
that you can see it 3 miles away, what the actual distance that you can see is probably 25 miles on the horizon. So you should be able to see a curve left to right as well, which we
let me
see.
let me correct you there, because if you're, and you can get a basketball or a yoga ball and put yourself on the top of it.
Yeah.
And when you look out on a ball, there's a tangent point where your eye line meets the curve of the ball, right? And if we were on a 24,901 mile around ball, that tangent line would be 3 miles away if you're a 6 foot tall person, and then you shouldn't be able to see anything out beyond that. So you're standing on top of the earth. Your tangent line from your eye, where you see the horizon at 12 o'clock in front of you, is 3 miles away, which we know it's not. It's much farther than that, but let's just pretend, right? And then at 1 o'clock, where is that tangent line? It's still 3 miles from you. At 2 o'clock, at 3 o'clock, 4 o'clock, it's still 3 miles from you. It's still at the exact same height in front of you, to the left, to the right, behind you.
I see what you're saying. Yeah,
you wouldn't see a curve. You wouldn't see a curve, right? You would see a circle, like you had your head in the middle of a hula hoop that you're holding up at eye level, right?
So, yeah, I see what you're saying, which is also, there's some people that say if you're standing on the top of the ball, you are actually standing in the middle of a donut, because you would see this hump of water in front of you. Yeah, but you don't actually see it because you're always on top of the ball. You're always right at that top point. Yeah.
Right. Well, you wouldn't see a hump. You would see a dropping off.
Exactly. Yeah.
I don't believe you would ever see a hump, because then you're leaning back and then your up is not up anymore. But this is the way we see. It's the limit of our vision. So when we're looking out, 1 o'clock, 2 o'clock, 3 o'clock, it's the same, right? So if you think you would see a hump, you have to follow that hump all the way around. And by the time you turned around behind you, you'd be pointing at the floor when the horizon's still at your eye level. So you would not see a hump. Now, if you saw a ship going at 12 o'clock in front of you, going perpendicular to your vision, at that point, it is getting farther and farther away, and it should go over a curve. But you have to separate that from actually being out saying that you would see a curve, because where the sky meets the ground, where you can't see any farther, that's the limit of your vision. We'll call it the limit, the zone of your eyes. So we'll call it the horizontal eye zone, right? The horizon.
Yeah. Dave, you got me there. I mean, I've been looking into this stuff for years now, and literally you've just opened my eyes to this one now. Anyway, let's move on to the next one, which is a huge one, which is gravity. That's the one that we always get attacked with in the comments section. I know we could talk for hours about this one, but let's hear your take on gravity.
Yeah, so gravity, we down is down, up is up, right? That they say we're crazy for thinking that. But let's talk about what gravity is. So gravity is a scientific, big quotation marks, laughing emoji, theory that mass attracts mass. And when you put it to the test, 96% of it is missing. Right. So what do you do when you have a theory that 96% of it doesn't work? You throw the theory in the garbage, and you take the garbage out. OK, so you have gravity as a theory, but then they say, well, there's dark matter and dark energy. No one's ever seen it. No one's ever measured it. But for gravity to work, it has to exist. Therefore, it exists. Now that's called pseudoscience and absolute nonsense. So they also tell us that gravity is a very weak force, right? So, gravity is a weak force. But the electrostatic force, and I know you guys have seen this, but let's show your listeners real quick. The electrostatic force is a scientifically testably measurable force, right? And the first argument before I get to that is, why doesn't the air get sucked off into space? They look, gravity's holding the air down, right? Gravity's holding the air down. So I have this balloon here. It's got a little bit of air in it, but it's sagging down because of allegedly gravity, right? The air pressure in the balloon is the same as the air around it. Now, if we remove the air from around the balloon, what happens to that balloon? We blow up the balloon, right? So put some air in the balloon or just put it in a vacuum chamber, it blows up. What is that air trying to do? It's trying to escape in every direction, including up, away from gravity, where gravity is the strongest, right here at the surface. It's trying to get out in every way because that's what gases do. They fill the available space. All right. So gravity holding onto the air is nonsense, absolute and total nonsense. So let's where is my you guys have me. All right. So the theory of electrostatics, well, it's not a theory, is that, you know, the earth is a giant battery, the sun and the moon are the anode and the cathode, the salt water carries the current. That makes sense to me. The land is a salt bridge, and that creates a living electromagnetic system. So how can we test that? Here's one that Zach, Good Times for All, did. He had some leftover party balloons, tied them to there's just a metal button here, and it's neutrally buoyant at, you know, a couple inches off the floor. Now this cord goes to a Van de Graaff generator, and we're going to add a positive charge. And when we add a positive charge, what's happening? It goes down, right? Because when we discharge it, it goes right back up, right? So the theory is that, well, not a theory again, the earth has a testable, measurable, neutral or negative charge, okay? The earth is not moving. Anything in the air is surrounded by a positive charge. So when you have something surrounded by a positive charge with a negative charge that's not moving next to it, it's like, hey, down is this way, right? And it pulls it down. It says down is this way, and then buoyancy and density sort everything else out. You know, handful of rocks, ping pong balls, and a balloon over a pool. Open my hand, the helium balloon goes up, the rocks and ping pong balls go down, the rocks go to the bottom of the pool, and the ping pong balls stay on the top of the pool. That's buoyancy and density, right? So we know that buoyancy and density is a thing. We know that we can make things change their weight, you know, go down by adding a positive charge. And, you know, if you look at the periodic table, every heavier element than the next one has a stronger positive charge than the one before it. Okay. So the higher the positive charge, the heavier it appears to be. Can we do the opposite? We add a negative charge into this, it goes up. Okay. Are we defying gravity or are we defying electromagnetism? So let's pretend that gravity is real. Well, science, you know, the gravitationalists, the globalists, they tell us that the electrostatic force, which is scientifically provable, testable, repeatable, is 10 to the 36 power stronger than gravity. Do you guys know how big of a number 10 to the 36 power is? I don't think our human minds can comprehend a number that huge, right? Because a trillion is 15 zeros. Okay. 10 to the 36 is 36 zeros. Every time you add a zero to a number, it just exponentially bigger. It's absolutely insanity. But they say that it's stronger. So let's pretend that the gravity also is real, because we know that electrostatic force is real. And I drop something. How the hell can you say that it's gravity that's pulling it down? The analogy I came up with the other day, and I think I like it, is you're in a boxing ring with Mike Tyson at his prime. And the thing that's going to make you get knocked out is something hitting your head. Well, there's several things hitting your head. There's air molecules hitting your head, and there's Mike Tyson's fist. Okay. In the globalist world, it's the air molecule that knocked you out.
Yeah. I mean, it's ridiculous. Even when you just think like, all right, if this thing's holding a skyscraper down, you shouldn't even be able to jump off the ground even an inch. You know what I mean? Why can you easily? I mean, it's just crazy.
And then if you look at clouds are electrostatically floating in the air. You know, why do these cumulus clouds have these beautiful sharp edges to them? Right? You know, they're lying about everything that we see. And this is the last one, silent drone, MIT. They're just changing the electrostatic charge. There's no moving parts. There's no sound, and it's flying. Are we defying gravity, or are we just playing with the electrostatic forces of the Earth?
Dave, one of the best ones that I saw is very, very short. You get an orange and you drop it into a bowl of water, it'll float. But if you peel the orange and then drop it in, it'll sink. So where's gravity there? I thought that was a very good one. Very, very simple. Yeah.
Right. And another one is if you have a pound of helium, you can get a pound of helium and put it in a balloon, and a pound of metal, why does one go up and the other one go down?
Yeah.
Right. Yeah. Anyway, and talk about gravity, the people love screaming gravity, gravity for everything. Gravity is their God. They say Jupiter is the largest planet and has more gravity than all of the rest of the planets combined. Right? Did you know this? This is what the gravitationalists, the globalists say. Jupiter has more gravity than all of the other planets in our solar system combined. Well, they also tell us that Jupiter is like 99% hydrogen and helium. How much hydrogen and helium that defies gravity here on Earth do you need to create more gravity than all of the other planets?
Yeah.
They just hope that you short circuit and just don't think.
How many moons does Jupiter allegedly have? Why hasn't it sucked them all into it and crashed them down if its gravity is so big?
Right. So here's a test for all of your listeners. What planet is this? Do you guys know what planet that is?
I know what this is, but
right. So you can argue with them and they'll be like, I'm like, that's Saturn. No, it's Jupiter. And I'm like, well, maybe it's Saturn, or maybe it's just a meadow with ducks in it. Okay. Okay. So your mind sees what your mind wants to see. Your mind sees what you've been programmed to see. And our perception of this world is based on our beliefs. And if you believe that you're flying through an infinite space on a random speck and that you were created from, a lightning strike out of an amoeba, then you've given up your divinity. You've given up your ability to truly thrive in this incredible realm that we live in.
Also, this is a good example because all of NASA's pictures of everything, even the Earth, are fake. And, we've got a P900 as you do. When we look at the planets, it doesn't look anything like this. They look like cymatic. They're changing colors and shapes constantly. Nothing you look at looks anything like this through a P900.
Right. When we look at Earth, which one do you like? I like the blue marble, right? Because, that's just my favorite. It's the excuses that people make is, it's just ridiculous. Being a glober is easy because you don't have to study. You just make up stuff. You don't have to do anything. Yeah. Being a flat earther really takes a lot of time.
Yeah. One of the things I saw your presentation, the flight paths fascinate me, the emergency landings, most especially. Do you mind if we talk about that in a bit?
Yeah, let's do it right now.
That's one of the arguments about the ball or the flat earth is, well, what about these flight paths, these long distance flights? And you're saying, what about the emergency landings that make no sense?
Well, you start off with the flight paths, and then if they're an intelligent person, the only argument they can come up with to protect their cult belief is that they have to make stops at hubs, or they have to change pilots. They make excuses for ridiculous flight paths. But you have to know that there's these counter rotating winds at different altitudes. These winds up here, I think, are like 300 miles an hour. Okay. And so here's a question. Let's say you and I both have a car. We're going to drive from New York. I'm going to go drive from New York to, I don't know, middle of the country somewhere, Kansas, whatever. And you're going to drive to California. Okay. But you get to California before me. Okay. What does that mean?
We were driving faster than you.
You were driving faster than me. Okay. That's all it means, is that you were driving faster than me. Right. And so let's look at a couple emergency landings. Here's one, New York to Hawaii. There was an emergency and they went, over 1,000 miles out of the way to Seattle, and they got there amazingly fast. Like, how did they get there in 15 minutes? Right. And if you look at it, Seattle is right on their flight path. So let's look at another one. This is, excuse my transparency. This is from London to Islamabad, and they stopped in Moscow, about 1,500 miles out of the way, I think. Okay, boom, Moscow is right on the flight path. Again, another one, Dallas to Beijing, stopped in Calgary. Why are they going all the way there? Well, Calgary happens to be just on the flight path on a flat Earth map, and there's tons of these. There's
I saw
many.
another one after. Yeah, I just saw one that happened in December of last year. They were going Singapore to London and stopped in Azerbaijan. They should have been flying over the Mediterranean on the ball model. And they were 1,000 something miles away on the other side of Turkmenistan. You know, it's just like, what?
This is my favorite one. This one is going from Hong Kong.
Yeah, they were 1,000 something miles away on the other side of Turkmenistan. You know, it's just like, what?
This is my favorite one. This one is going from Hong Kong. They stopped in Germany. They were supposed to go to the UK, 12-hour flight. And about 4 hours into the flight, you know, about here, there's a family traveling together, father, mother, 2 small kids, and the mother died suddenly. That's all we're going to say. Died suddenly. She's dead in the chair. So what does the pilot do? Well, let's land this plane. Let's land it here. Any one of these airports. There's not a million, but there's dozens and dozens and dozens of acceptable places to stop. But they didn't. They flew for 8 more hours before they finally stopped in Germany. That's insane. Think about those poor little kids sitting next to their dead mom, right? I make the joke, imagine sitting next to your mom for 12 hours when she's alive. Okay. Which isn't horrible. It's a 12-hour flight. It's just brutal. But the people on the space station for 6 months, they're fine. They're doing great, right? Imagine being on an airplane for 6 months. Okay. Here's the actual flight route. 4 hours into the flight, they're over Russia. Okay. They're over Russia. Well, what are you doing over Russia? You know, if they landed, Russia would be like, let us help, let us be the good guys, you know, because they are the good guys. And if they landed in Russia, they'd be like, why the heck did we land in Russia? And the answer is because the Earth is flat, right? And at this point, 8 hours, why didn't you just get the family home? Why didn't they just finish the flight? Okay. Sorry for I'm don't have my normal studio here, so I have some lighting issues.
Yeah, that's okay, man.
Yeah.
Who do I?
Last one, New York to New Zealand, right here, emergency. They went to Fiji. Why'd they go to Fiji? Because Fiji is right on that line on a flat Earth map. Okay. How many do you need? Do you guys have the book yet? 16 Emergency Landings.
No.
Great book. It's free online. All the work has been done for you. You can get the PDF online. If you want it as a coffee table book, I highly recommend it. Lulu.com, 16 Emergency Landings. It's amazing because if you have it on your table and you invite some friends over for, you know, drinks or dinner and they pick it up, they turn into flat earthers. You don't have to do anything. The book alone will plant enough seeds that turn them into flat earthers.
I mean, even 3 of these things, even 2 is enough. You know, 1 you could say, there could be, but you know, if this keeps happening, 3, let alone 16 and 20, and there's more probably not in that book. I found a few from last year. I found one in the United States where they took off from Atlanta. They were supposed to be going to Sacramento and ended up landing in like Memphis or something. And it's just like, why would you fly, 800 miles north or whatever it was? It didn't make any sense.
I think there's quite a few of them that actually go from the southern hemisphere into the northern and then back down into the southern hemisphere again on the globe.
Yeah. What about, I wanted to ask you about the starlight. I don't know if it's called the inverse square law. I can't remember the law, but the light loses intensity over distance. How is it possible you could see stars from trillions of light years away? How is this possible or not possible?
It's not possible. It's not. Oh, okay. The distances to the stars. Yeah. And again, I do the math all the time, and it's really simple, but normie people don't know how to actually apply math. So they tell us, science tells us why the sun and the moon are different sizes, but the sun's 400 times bigger and it's 400 times farther. Therefore, they're the same size, or perhaps they're just the same size. But let's pretend the distance and scaling work, right? If you do the inverse square law on the size of the sun, move it 400 times farther, it'll become the same size as the moon, according to their math. And as we showed you a little while ago with the lines,
can you explain
math can describe anything? Sorry.
Can you explain to people what the inverse square law is, just in case they don't know what you mean?
Yeah, when you have an object, the brightness of an object or the size of an object, and you double the distance to it, it is now 1/4 of its brightness or size. So, and then if you double that distance again, it's 1/4 of that size or brightness. Okay. So if we look at the moon, let's look at the moon on a full moon night. You could read by it. It's so bright, it's casting your shadow on the ground, right? It's sending light. Let's pretend it's only 1 lumen, right? And we travel halfway to the moon. It's now 4 lumens, halfway again, 16, halfway again, 64. Keep going until we're 100 miles from the moon, and the moon would have to be magnitudes brighter than the sun from that point of view for us to see it at 1 lumen from Earth. When I say magnitudes, it's like 60 times brighter than we see the sun. You can't imagine what the sun is at twice its brightness. You've never seen anything like that, right?
Yeah.
So
that debunks the moon landing right there, because when they're showing their moon landing footage, it's not, they're not standing on the sun. It's like dark, right? Even though they're in the daylight, so they're clearly not there.
A dusty, dirty ball reflecting light that far where it casts your shadow on the ground and you can read. Nonsense, right?
Yeah.
And Jupiter is worse. Go out and look at Jupiter in the night sky. It's literally, it's a star. It's brighter than any other star, right? It's so bright. You have to believe that dusty, dirty ball is reflecting sunlight all the way back to Earth, and you see it as brighter than any star. Think about it. If you were on Jupiter, the sun is much farther away than it is from Earth, so it's a smaller sun. It's not even a sun the size that we see it. It's a tiny sun reflecting off of the gassy, non-reflective surface, traveling all the way back to Earth where we can see it with our naked eye, bright as can be. I'm sorry, you're being lied to about what that light in the sky is. It's not a helium and hydrogen supergravity ball.
Yeah. One of the things Ross and I were talking about too is they say space is a vacuum, but then they say there's particles in it. Like Ross said, well, what are all these Oort clouds? In fact, they tell us the Big Bang happened and all the particles gathered with gravity into planets and all this stuff. So why don't the stars light up those particles? Space, should it not look more white than black if there were starlight hitting particles? And
the whole idea of space is just so nonsensical that asking a question like that, there's so many problems with space. I can't even get to that question. Okay. I can't even get to that question. How are we able to zoom in on this? So this is 211 trillion miles away. Okay. 211 trillion miles.
Yeah.
Your brain can't comprehend what that is.
We shouldn't be able to see that at all.
You shouldn't be able to see it at a light hour away. Okay.
Yeah.
And the brightness issue for one, but they tell us that that Polaris is 433 light years away. 433 light years away, and each light year is 25 is like not 25. It's like 7 trillion miles, whatever it is. Number is ridiculous. You couldn't see if we have the sun, it's 93 million miles away. If we doubled the distance to the sun, it would be a quarter of its size. Double it again, it's a quarter of that size. So it's a 16th. Double it again, it's a 64th, right? And now it's 8 times the distance. It's so small, it's the tiniest star. You can barely see it. So that is actually 1 light hour. The sun's 8 light minutes away, 8 times as far. is 64. We'll call it a light hour, right? So,
Yeah.
so the argument is, could you see it at that distance? And we can go back and forth. Well, you know, maybe you could, maybe you can't. You probably can. Let's double it, make it 2 light hours. You know what? Let's just give the ball everything it wants. We'll make it a light day, 24 times farther. Okay. Then it's scientifically provable beyond any question that you couldn't see it. All right. So remember the scaling and distances with the sun and the moon. Well, let's do it with the sun and Polaris. Polaris is 48 times bigger than the sun, they tell us. So we'll make it 48 times farther. So if we had the sun of the light day away, which is ridiculous, couldn't possibly see it. So we'll put Polaris at 48 light days away. Let's round it up, 2 light months. At 2 light months away, it is scientifically beyond even questioning that you could not see it due to its angular size, let alone the brightness issue, right? The brightness issue would be so dim that I don't even know if you could see it if you were next to it at that brightness.
Yeah.
All right. That's 2 light months away. They're telling us it's 433 light years away. Everyone's brain just short circuits. I don't know. A guy in a bow tie told me, and therefore it must be true. Okay. Yeah. So again, when you actually apply your God-given common sense, you realize that these things are impossible. Now, what are stars? The Globers will come out. Oh, well, what are they? Well, I don't know. You ask me, I think they have to do with souls. I think they're souls, you know, and the wandering stars, which we now call planets, are all named after gods. Okay. I don't know what they are, but they're not these burning balls of gas in a space vacuum, right? You know, you think about, you know, where do stars come from? You know where stars are made? They're made in a nebula. Remember, you know, this nebula, right? This is a star manufacturing. What's a nebula? A nebula is dust and gas in space that's collapsing upon itself, creating stars.
Right. In a vacuum.
That have gravity. And when they're done, when enough dust and gas combines and turns into a nuclear furnace, it pops it out like a ping pong ball machine, and the star rolls and stops in a perfect spot in the galaxy. Okay. I mean, what the hell are they talking about here? Okay.
What is that picture anyway? That's clearly digital. That's art. It's digital art. That's CGI.
That's all it is. It's all it is. It's all it is. I mean,
you made a good point with you made a great point, and I tell people that too. I say, like, we flat earthers don't claim to know what everything is. We know what we're not on and what isn't, you know. And I tell people, if you're coming over to flat earth, don't expect all the answers are there for you. You know, you're not going to replace one belief system with another. It's a community asking questions. And, you know, as everyone says, they won't let us go up there. They won't let us go to the North Pole. They won't let us go see if there's an ice wall. Everywhere you try to go, you're blocked, or there's a treaty. Well, so, you know, people have to be careful. We don't, there might be a firmament, there might not. We don't know what stars are. The moon could be holographic. Nobody really knows what's going on, but we know what's not happening. And that's the story we've all been sold.
Yeah, absolutely. So the two places that would actually prove that we're on a ball or on a globe are Antarctica and the North Pole, and both of those are somehow off limits, right?
Yeah.
Do you find that weird?
Yeah, like you can't go there. There's military will shoot you down or chase you away. Yeah, it's crazy. And they have treaties. All the countries around the world are allegedly at war with each other half the time, all have the same treaty together though about these lands. You know, it's crazy. Yeah,
absolutely.
And it's the only treaty that's never been broken.
Here's 100%. And they're hiding, you know, people are like, well, how come you can just go there if the earth is, you know, big pond like you tell us? Why can't you sneak over here or sneak over there? It's because it's actually guarded. I'll show you that in a moment. But here's Google Earth. Anybody can do this themselves. Go on your browser, go to Google Earth and get out the measuring tool, and let's measure the United States. So you draw some lines around the United States and it shows you, bam, that's square miles. Very good. All right, cool. Pretty good. Let's try something in the South. We'll go to Australia, draw a line around Australia, and it'll give us the square miles of Australia. You know, if we believe it or not, it's not the issue. And now let's go to Antarctica. Have you guys seen this?
No, I haven't seen this done.
Yeah, and you could do this on, and you have to go to the web version of Google Earth, right? And you click it, and what's that?
Whoops.
Okay,
Hmm.
what is that?
Yeah, exactly.
Good question.
I also saw someone was checking shipping routes or something and found a ship sitting in the middle of Antarctica. Do you know?
Yeah,
Is that you
So,
or-
well,
What was that?
a bunch of people found it, and then I went and looked, and I found it, and this is you've seen this map, which was found in a Buddhist temple and published in 1910, I think, in a Hawaiian magazine or a newspaper, and it's showing all these other continents. So you know how we always talk about the ice wall. I'm kind of, I don't know if there's an ice wall that goes all the way around, right? Maybe everything outside of this line is frozen at times. Okay.
Yeah.
But maybe it opens up sometimes, right? And the ice wall is actually way, way farther than what we call Antarctica. But if you were, check this out. So you want to go to Antarctica, you go from Santiago, right here, and you go south. And let's say they took you right to the center point on this shoreline, okay, of this continent. Now look at this continent. Is that an island? It's bigger than the United States, Canada, and Mexico. It's twice as big as all three of those combined. So we land you right here, and we go, welcome to Antarctica, and it's frozen. Welcome to Antarctica, right? And would you know if you were in Antarctica or not? Would you know? Your brain program tells you that you're upside down, standing on the bottom of a ball at the edge of an island continent called Antarctica. How would you ever know where you are? Right?
Yeah.
So we'll go. Then here's one of the shipping tracking websites, and I've actually tried to find it again since then, and it looks like they've corrected this anomaly, but there are ships inside, hundreds of miles inside of Antarctica. And so this one, they clicked on it, and very little information. Normally there's tons of information. The only information they gave was that it was 580 meters long. That's a giant ship, 80 meters wide, 580 meters long. That's a gigantic ship, and where it was registered. So it was registered on the island of Kiribati. Have you ever heard of it?
No.
You haven't heard of it because it's here. It's in the middle of nowhere. I got a pin on it because you can't even see it, right? And we zoom in, and this is an island that the United States and China are very, very interested in, right? Okay. This is like a sandbar. Sand people live here, okay? It's got a ship so big that if it was carrying supplies for this island, it could supply them for decades with one shipment, okay? And what is that ship doing heading south and end up in the middle of Antarctica, right? I contend that it's making shipping routes to the outer lands, right? It's going from here, shipping, who knows, technology, forward and back, trading food, little girls. I don't know. We don't know what's going on out here. And the question I have is, how would you know? How would you ever know? What if there's hundreds of these boats going out here, and there's a whole nother civilization of people, trading technology? Like, in the 1950s, we didn't even have televisions. And now we have computer chips that are allowing the three of us to talk, like we're in the same room. Where did those chips come from? Who came up with this? Maybe there's advanced worlds right here outside the extraterritory, right? Maybe the extraterrestrials are just advanced people here and, in our realm.
What's crazy is that 1480 Monty's planisphere map, the one, I think it was like 15 feet big.
Yeah.
It shows lands mapped out, not ice, but mapped out all around the realm we live in. And it even has like town names and like shows where mountains and rivers are, and you have to say like,
strange.
What this guy just, what he just made that up. Like he drew a perfect replica of the earth and then just decided to put all these massive lands, and they're way bigger than anything in here that we know of. They make Africa look tiny.
Yeah,
So
yeah. So
you
this
do
is
have to
kind of
wonder.
like a
Like
depiction
that, yeah.
of that, right? So what's out here, right? And I love looking at this one and saying, what if we lived here? This ring is Antarctica. Here's more land. So this might be the edge of our pond, right? And then if you look at it, you guys have seen this map. What if this is, where we live? What if that? And again, I am speculating. Anything beyond the shoreline of Antarctica, we don't know, but there's tons of evidence that say there is stuff going on out there. We want the right to go explore. So does this prove what I'm showing you here? Does this prove anything? No, I'm saying we want the right to go prove or disprove this. Okay.
Yeah.
So we live here, right? Here are other pieces of the plane, right? Ponds holding up, occupying pieces of the plane, or a planet, if you will, a piece of the plane. All of these extra worlds.
Suns. They each have their own suns, kind of. Is that the idea?
They all have their own suns. Maybe some of these ponds have more than one sun. The outer ring has another sun going in the opposite direction. So this could just be how our world is. Again, we don't know. We want the right to explore, and
isn't Disney World set up like that? Actually,
Disney World is set up like it's the map, and then they all have underground tunnels too. Think about that.
Yeah, that's crazy. Well, there's your extraterrestrials right there.
Yeah, the extra terra.
Yeah,
here on Earth, scientifically provable.
Yeah, well, it makes more sense than coming from light years away that don't exist probably anyway. So yeah, Ross, did you say you had some other questions too?
Yeah, well, in fact, the questions that I had from our comment section, we've basically touched on every one of them anyway. So,
yeah.
let me put a challenge. Excuse me, I'm losing my voice here.
Let
me get a challenge out for everybody. I offer 3 Bitcoins for 1 globe proof. 3 Bitcoins, 1 globe proof. So if you're so sure that you live on a spinning, whirling, twirling ball going through infinite heliocentric space, all you got to do is on my app, the Flat Earth, Sun, Moon, and Zodiac Clock app, every day there's a new video that'll teach you. So while you're having your coffee in the morning, click this right here and watch the video. Do it for 2 weeks. At the end of that 2 weeks, if you think you have a globe proof, you can send it to me. But before you do, hit the question mark button. And when you do, your question is probably answered here in these 28 questions, right? 28 sections. Gravity, why the lie? What about the ISS? What about southern star rotation? They're all there. The 24-hour sun in Antarctica, that's a good one. If I click it, up comes a list of videos that Google doesn't want you seeing. They don't want you seeing these videos. They'll hide them from you. But the app bypasses their algorithms and will answer all your questions. And then you too can be ostracized like we are from our friends and family because we're flat earthers. But that's changing. There's tons of people.
Just ask Dave, how many people you got now on
so everyone that has the app, not everyone is on the friend finder, but if they go on the friend finder, it creates a blue dot. And look, this is people in the UK, right?
Yeah, that's pretty impressive.
These are people, look at the United States. It's incredible. Where are you guys?
Denmark.
You're in Denmark. So let's go here. I'll click the flag and I'll put in Denmark. Let's see how Denmark's looking. Ready? Let it load. Oh, Denmark. Look at that.
Quite a few, yeah.
You got people all over the place. And you can message people. Like I can set the radius. I have it set to 50 kilometers and there's 31 people. I can send a message like, hey, everyone, we're meeting at Steve's house. Bring your own beer, Saturday, 4 o'clock. And then everyone shows up. And I've never met a blue dot I don't like. Right. Yeah. Every one of these people are not afraid of the boogeyman. They're awake and aware that we've been lied to, and they're awesome unplugged people from the heliocentric matrix, right? So the app is an amazing way to get people together to collaborate because, when you're working on this alone, the biggest complaint a few years ago was, flat earther, I can't talk to anybody. I'm going crazy. Yeah. Then they look on the map, they go, oh, look, that person's right near me. And they click on the dot and they say, hey, let me send a message to that person. They'll look at their profile. Let's meet for coffee at Joe's coffee shop. And now you have a new best friend. Okay.
Yeah.
So we're using their technology to, bring us together. It's amazing. And, you know, the app has so many other features to help educate yourself, right? I made the app for myself, right? I wasn't even going to publish it, but then I published it and they're like, hey, can you add this? Can you add that? And add this, add that. I'm adding all sorts of stuff. There's a new trivia game that's going to be on it really soon. That's going to be a blast. Like you play it with your Globey friends and it's game over.
One
Or you
thing
play
I
it with
find
your flat earth friends.
incredible. Yeah, it's incredible how large the flat earth movement has gotten since, you know, I don't know when you started. We started looking, I don't know, 4 or 5 years ago, but it's
Little ahead.
I say to people, do you really think that millions and millions of people would suddenly just start claiming the earth was flat for no reason if there wasn't some proof? You know, it's not just something everyone decides to start saying.
It's nobody wakes up in the morning and says, hey, I want to be a flat earther and, you know, really, you know, have everybody come down on me. But now, you know, you mentioned flat earth to somebody, they're like, really, tell me more. Right. And having the app in your hands to pull up the images, to pull up videos, answer questions. It's an awesome tool. And the question you had is the number of people on the friend files are 91,200 right now.
Wow.
All right. And it's growing, you know, by hundreds and hundreds. It's like 100 a day or more right now. So
yeah, if it was like the Globies claim that it was just rubbish and whatever, you wouldn't get 91,000 people joining.
And in the comments, you know, you watch a flat earth video and you're like, oh, that's really good information. Let me look at the comments. And then the comments steer you away from what the video said, because you got someone in there, you go, flat earth is a psyop. Flat earth is stupid. You know, the cats would have pushed everything off the edge by now. Just a whole bunch of nonsense, but they never offer globe proof. And if you click on their channel, you go to the channel, there's no content on their channel and they have 0 subs. So what does that tell you? You know, I say they're either paid or possessed. You know, there's bots out there. There's people that defend the globe and don't know their model. And what I say is flat earthers know so much about the globe model. That's how we became flat earthers. If a globe person knew 1/10 of what a flat earther knows about the globe model, they would be a flat earther. There's no way you can look at the globe model and say, oh, yeah, it's a globe. Because when you actually look at it, everyone believes it, but they don't know why. They don't know why, right? They don't know why they believe in the globe, right? And they say, where's your map? You know, well, our map is the Gleason's map, okay? Our map is the Gleason's map. That's the best one that we have. Let's say that it's used for navigation. It was in all encyclopedias. It was in all schools, libraries until the 1950s. And then it was all of a sudden removed. Why was it removed? Why do all of like the UN and all the big agencies of the world use it as their logo? Right. But when you say, they say, we don't have a map, this is the globe. Okay. The dark is the actual size and the blue is the size that they show you on the globe. You don't have a map. You don't have a map.
What do you say when people say, what about the blue marble? I've seen that taken off NASA's website, and then you start changing the gamma and there's like a clear cutout box around it that thing was pasted in there. No.
The blue marble is the one made by Robert Simmons, and he is a NASA visual artist who said that he made it all from data. He painted it in Photoshop. There's a famous interview with him saying, you know, it's Photoshop because it has to be. And then there's other ones where, you know, if you look at, we took Rob Skiba actually took the image from the NASA's website, the photo of the Earth from the moon, and then cranked up the levels and you could see the box around it.
And I'm going to show you something else right here, live right here on the air. Okay, Apollo 17. This is nasa.gov, their website. It has all the different NASA missions. Now, this picture right here, Earth in full view, is from Apollo 17. It's the most famous of all the pictures of the Earth. This one right here, Apollo 17. They always have to show you Antarctica too, by the way. It's interesting. Most of the pictures of the Earth will try to get you to see Antarctica. Okay, scientists on the moon. Click on this picture right here. Supposedly the same mission, same guys that took the picture of the most famous picture of our Earth. I'm going to do save image as. And let's see, Apollo moon. Let's call it Apollo moon 17. And I'm going to open that in Photoshop. And do you guys still see it? Okay. All right. Do you see Photoshop?
Yes.
Yeah. Okay. And if those of you think this technical difficulty was planned and think I'm scamming you, go do it for yourself. because you're going to find the exact same thing. I got nothing to hide here. This is live on the air, okay? I'm going to zoom in on the Earth in Photoshop. Can you see the Earth?
Yep.
Okay, I'm going to go to Image, Adjust, Levels, and I'm going to bring the levels over here. And I'm going to bring the levels up. Uh-oh. What is that?
Oh, wow.
Yeah, wow. Why is there a square box around the Earth allegedly taken from the scientists on the moon in Apollo 17? And people wonder why I don't trust NASA. That's why I don't trust NASA. I mean, they're always out there saying, you know, Rob, everybody's trying to show you stuff from space, and you keep rejecting it. This is why I reject it. These guys are liars. Anybody who has Photoshop can just go to the NASA website, download the photo, do exactly what I did, see for yourself.
That's the one I'm talking about. Yeah, that's the Earth rise, and the clouds didn't move. The Earth's supposed to be spinning at 1,000 miles an hour, and it takes 15 minutes to rise, and the clouds are in the same spot. You're like, how did
Right. Well,
it
there's
rotate or what?
Just to show you what sort of a NASA fanboy I was. I had an 8mm film of the Earthrise.
Yeah.
Yeah, when I was a kid, I actually went
Yeah.
that far and bought the film, 8mm. But it's that one you're talking about, Steve. It's the Earthrise over
Yeah.
the moon, from the moon landing.
From the moon, yeah.
yeah,
It's-
and
it's-
that, you know,
Yeah.
he's lazy using the same clouds. Everybody's seen this. Okay.
Oh, cut and
It's
paste the clouds.
It's the cut and paste the clouds. It didn't even bother making it, any different. You know, he's just using the same clouds, right?
Yeah, and the continents are even different shapes. In the one you showed an image earlier with like 8 different Earth pictures.
Yeah.
Sometimes they're orange, sometimes they're green, but the continents aren't even the same size.
No, they're
You're like, well,
horrible.
the weather could change, but like, how could the continent change? You know, clearly those aren't pictures, but people
Right.
believe this. This is one of the ball proofs. Is this
Right. People say, well, you're looking at it at a different angle. Well, you know what? When you take something and you're looking at like a circle right here on my hand, and I tilt it away, it gets smaller from your point of view. So this
Yeah.
is the United States tilted away. It should be smaller. It's twice the friggin' size. Okay.
Yeah, completely. It's
Yeah.
crazy, isn't it?
Yeah. It's
Look at the clouds. Yeah, I mean, they even have the same cloud patterns. It's crazy.
wait, check this out. 1978 and 2017, same exact clouds, right? This was a picture NASA showed saying pollution is dimming the world, and they show us, oh my God, it's so scary. Look out that we're losing our bright colors because of pollution. Same clouds.
Exactly. Yeah, that's crazy.
Same clouds.
Also, what's that Voyager, right? Shouldn't they have taken a picture of the Earth if they really sent this Voyager out or whatever it's called? They didn't turn the camera around and take a real picture of the Earth. Wouldn't
No.
you think that would be like important?
Right. And people are like, well, what about the James Webb telescope? Look at these awesome pictures it took, and they show us a picture like that. But, actually, that's not one of theirs. That's a countertop. They, and then they show us this amazing picture, 4.6 billion light years away. And then, some mass shooting happens, and from 10 feet away, this is what we get. 4.6 billion years away and 10 feet away.
Yeah, like
Right?
Nixon's phone call.
What's that?
Like Nixon's phone call to the guys on the moon.
Yeah.
Oh, yeah.
As if.
Right.
Yeah, we
And
can't
then,
even get a connection around the corner even now.
Yeah, that's just absolute insanity. It's so crazy. It's so crazy. But if you watch I don't want to get into the whole thing now because we're going to run out of time. The whole James Webb telescope, it's so stupid. So they launch it into orbit. It gets ejected from the nose of the rocket just in Earth orbit, and then somehow it flies another 1,000,000 miles away and parks itself in a Lagrange point. You know what a Lagrange point is? Lagrange point is supposedly where the sun's gravity and the Earth's gravity are equal, right? Closer to the Earth because it's smaller. And then it'll just hold itself in that spot. As we corkscrew through space in 4 different directions at once, that just mirrors all of those motions, right?
That's our geostationary satellites, so-called. Yeah.
Yeah. How the hell is that possible? How is that possible?
Have you wondered about satellite dishes as well, Dave?
Well,
Why
satellite.
you never see a satellite dish that's pointing straight upwards. Never.
Well, you know what? Before we had, our normal satellite dishes, that we have today, the little ones. We had big ones, and my father lived in the Caribbean, off of Puerto Rico, and this is before cable TV and stuff. And he had a I don't know, probably a 15-foot wide dish on his roof that actually you move it to 5 or 6 or 7 different positions where it locks in on a satellite. Cool, right? But you have to think these satellites are following all of these motions of the Earth and somehow staying in the same position in space, right? It's falling around the Earth. That's what an orbit is. And the Earth is falling around the sun, and everything is chasing the sun. Okay. Mind short circuits, can't comprehend. A guy in a bow tie told me it has to be real. Okay. He was wearing a lab coat too, so it must be real. So he had this thing, and we would move it, and then it would pick up a whole bunch of feeds and stuff. And boy, I wish I knew what was going on, because some of the feeds were the network sending raw footage to the other networks, to the other stations. And you got all of the raw footage, on camera, off camera stuff. There's probably gold mine of stuff in there. But what I think that was doing is they're just transmitting up to the firmament, and it bounces off the firmament and goes in all directions. All you have to do is point your dish towards that point on the firmament, and that's how you get the signal, right? If you have a signal and you beam it up straight up, it's going to hit the firmament if it's, as they say, and it's going to bounce back in all directions. All you got to do is point your dish at that spot to get the signal. And I think that's what was going on back then. But now, Dish TV even admits they're using towers. Your camera, your dish is pointing towards a tower.
It's sideways, dead sideways. It's crazy.
Yeah.
I mean, Polaris, that model you have spinning in the background right now, Polaris disproves that. You've got the North Star sitting dead still with all the stars spinning around. Polaris would not be sitting still if we were doing that.
Right. And we're talking about Polaris and not being the Southern Cross. You can't see the Polaris on a globe past the equator, but there's been many sightings as far as 30 degrees south when the weather conditions are clear enough that you can see Polaris. That's impossible.
Right, because you'd be underneath the ball, you'd be under a curve, so you couldn't see through the Earth to the star.
Yeah, absolutely. Let's do another one where rockets. Where's my rockets? The Go Fast rocket, right? You guys are familiar with that, right?
Which one?
The Go Fast rocket. So this is a rocket. So this rocket was
this SpaceX stuff here.
No. This was an amateur rocket. Went up 72 miles, and all of a sudden it went kerplunk.
Oh yeah,
and hit something like plasma, and then it floated kind of weird. And it was an uninterrupted feed too. One looking down, one looking sideways. NASA never gives us that. Now NASA, before it clears the launch pad or SpaceX, you have 7 different edits. Edit. It's like, just show us the whole thing. But it saw the moon. There's the moon. Okay. The problem with that is the moon, when this took off, so this took off in Arizona, the moon, so Arizona's right here. The moon was over Australia.
Shouldn't be visible.
All right. So if the Earth was a basketball and that rocket was on the top of the basketball, it's a fraction of a millimeter above the basketball, and the moon is directly below the basketball. Okay. Could you see the moon? Because the Earth is flat.
Yeah, exactly.
The same thing is why sometimes when there's an eclipse, why can you see the sun and the moon in the sky at the same time?
Yeah. Eclipses actually prove the Earth is flat. But if you believe that the Earth is casting a shadow on the moon, then you're going to have a hard time understanding that, for a lunar eclipse. And, the sun, the solar eclipses are very amazing. On my app, which can be found at flatearthdave.com, if you go to the eclipses section, so I mean to the frequently asked questions and then eclipses right there, up come some videos, and these two, whoops, not what I wanted. There's two on there. I can actually pull it up. Let me pull it up. It'll be easier. There's two on there that show how I think the eclipse is being done. Have you guys ever seen my rear projection eclipse?
No, I don't think so. I've seen some of Cami Nodell's work. I'd like to see this.
Yeah, I think you're gonna like this. So here is a real eclipse that I filmed. And by the way, I did not put on the blinders that everybody wanted me to wear. I looked at it with my naked eyes the entire time, and I'm not blind. Okay. So here's an eclipse I filmed. So what do we see? We see the sun. We see the sun. Oh, you know what? I'm not even showing you the right picture yet. I'm going to double back. So here's some photos of an eclipse. All right. So you guys see this, right?
Yeah.
So here's a photo eclipse. And what do we see? Do we see the moon? No, we see the sky. Just like around, we see it looks like the sky. The part that's being eclipsed, we don't see the moon. We're programmed to think we see a moon, but it's really showing me the sky, right? This has a filter on it, so it's still black. So you're seeing black. The eclipse part looks like it's just like a piece of the sun is missing, right? We don't see the moon. We see the sky. We see the sky, right? It all looks just like it's revealing the sky. So yeah. What is that? So now let me show you my rear projection eclipse. So this is an eclipse I filmed, and this is an eclipse I made. All right. So let me just jump forward a little bit here. So this was an eclipse that was filmed. The eclipse is like 85-90% eclipse. It's this much of the eclipse is happening, but you can't see it because it's just so bright, it's blowing the lens out. But this is an 85% eclipse right here. But we had these two things. Well, this is a lens flare because it's moving around. This one, we're trying to figure out what it is. It's locked in position with the sun. Okay, so what is that? And I contend that that's the real sun. This is the real eclipse that's happening. And we see in our personal atmospheric dome, right? So the sun, the real sun projects itself into our reality. We see it where we see it, like we talked before, right? So here's my, this paper towel is my representation of the sky, and I have the source sun behind it, and I'm eclipsing it with a round object, which happens to be a Snapple iced tea cap. And it creates this sun, okay? So it creates this. Now, during an eclipse, no one has ever, from any position, space station, airplane, ground, infrared, nothing, no one's ever spotted the moon. No one's ever seen it eclipse the sun or exit the sun, okay? Or approach or leave. So that's because there's no light on the bottle cap facing the earth. Therefore, there's nothing being projected. Okay. So then I did it again with a thinner piece of tissue, right? Here is the source sun. Here's the sun that we see. And all of a sudden we can see the source, the projector behind it. Okay. And we compare that to what we actually saw during an eclipse, you would see they look exactly the same.
Right.
All right. They look exactly the same. So did I prove it? No. Did I show you how it could work? Absolutely. Right. And under certain conditions, you know, sometimes people say there's two suns in the sky in Saudi Arabia or whatever. It's look at the sky conditions. The light of the sun is dimmed so much that you can actually see the source. Right. I contend this is always here. You just can't see it when the sun is at its full brightness.
Because it's too bright to look directly at
it's too light to see. It blinds you. You can't see it. But when what that
is, eclipsing it back there, what's eclipsing the source light? Are you saying there's another object?
It's interesting. There again, we don't know, but you know, everyone says it's the moon. You know, and you know, a lot of flat earthers say it's not the moon. You know, because when there's a new moon, you don't see it. And so a lot of us contend that, when there's a new moon, maybe there is no moon, but the eclipse always happens when, if you track the positions of the moon, the eclipse always happens when the moon should be right in alignment with the sun. But I say, instead of the moon eclipsing in front of the sun, the moon is eclipsing behind the sun.
The source of the sun.
The source, the projector.
Yeah.
If you ever watched a movie, a rear projected movie on like a bed sheet, in the park or something, if you look hard at that sheet, you can see the projector, the light behind it. You can see the light that's projecting. And I think that's how we see the sun.
Dave, just a quick question on this subject as well. Something that I've not been able to get my head around. During an eclipse, people have taken lots of videos of the shadows with multiple images of the eclipse on the ground in the shadow. Have you seen that?
Oh, yeah. Like if you look at the shadow, if you look at the shadow of the eclipse going through like the leaves on a tree, and casting the shadow on the ground, it's crazy. It's like you see multiple. I don't know. I don't know what it is. I can't
get my head around that one.
Yeah. Have you seen the experiment that Cammie and Zach do with looking at the sun, and they put a piece of polarized film? Okay. Then they put another piece of polarized film and they turn it, and then you can't see this. It blocks everything else out. Makes sense. Then they put a third piece of polarized film over this that's already blocking it. And there it is again. It makes it visible. Okay. It's beyond my ability to fully understand what is going on there, right? And think about this. I'm trying to keep this YouTube friendly. The governments of the world they all agree on certain things. They all agree nobody can go to Antarctica. Okay, right? There's more resources there. Admiral Byrd says, no one's living there, no animals to disrupt, nothing. Oh, no, nobody can go there, right? We can't go there, right? Everything we need resource-wise that we're having wars over, can't go there. All the countries in the world agree. The boogeyman's here. All the countries in the world agree. Everyone needs to get the boogie booster, okay? And everyone agrees, okay? All these warring countries, we all agree. And then the third thing is, when there's an eclipse, don't look at the eclipse, you go blind, okay? What happens when you tell a group of people not to do something? There's a large percentage of them that are going to do it. How many people have you heard that have gone blind from looking at an eclipse? Okay. None. I think there was like one report in the 70s, like a guy looked at the eclipse, and basically that was just to scare everybody. And it scared me for years. It wasn't until 8 years ago that I started staring at an eclipse with my eyes open and refusing to blink. Okay.
Well, for years we've had sun gazers, people who just gaze at the sun all bloody day.
I can't do it all day, but I do it, within a good hour or so from sunrise or sunset, and it's amazing. It helps my eyesight. After that eclipse, literally we were there for like 2 hours watching the eclipse, and my eyesight was better. Right? I'm not telling anyone to go stare at the sun. You have to, it's like going to like, if you've never been to the gym, don't go bench 200 pounds. You're going to hurt yourself, right? Learn about sun gazing, learn about it. And, when all the governments in the world are willing to give you free blinders, it's because they don't want you to see something.
Yeah.
Right?
Or see nothing's there actually,
Yeah. I mean, my sun fade out videos, right? You guys have seen those. Yes.
Yeah,
of course. The sun fade out videos, all of the Globers are like, use a solar lens, use a solar filter, use a solar filter. And when you do that, you can't see anything. Okay. It literally hides, everything. Right. So here is, this is a ground one. Hold on. Not the one. So this is the sun. It was going down, 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 and it stopped. And it sat here for 10 minutes. Okay. If the earth was spinning, game over. I'm not talking about the size of the sun. I'm not talking about the fact that it's slightly blurry. I'm talking about the fact that it stopped going down, right? If we're spinning, it should just keep on going. It sat here, and then as it went away, it took its light with it. Okay. Light doesn't travel for trillions and miles and billions of years. It only goes as far as it goes. it went away.
Right.
That's all I got to say about that.
Yeah.
That is crazy.
Anything else? Hey,
Yeah. I mean,
unfortunately, I got to. Go ahead. What? Say again.
You know, as they say that light travels forever. That's why we can see the stars and everything. But if that
I know
was true,
it was burned out 1 billion years ago, and we're looking
Yeah.
back in history. It's so cool, man.
Exactly.
That's so cool. It's so
But, I mean,
cool.
if that was true, if you were in a white room, but there was no lights on, no windows or anything, completely dark, and you turned on a flashlight, that shouldn't just illuminate where you're. It should be bouncing off all the walls constantly and lighting up everything. But it doesn't do that. It's not what we see.
Yeah.
We see the torch lighting up the corner or one wall or something. So what they're saying, that light travels forever, is absolute rubbish. And you can prove it with a flashlight, you know?
I know.
Yeah. I mean,
so,
just like you can prove water to stick into a ball by turning on your washing machine and your jeans fly to the outside, you know, that you can see its centrifugal force. There's no way water would be sticking to a spinning ball at 1,000 miles an hour.
If the Earth is spinning at 1,000 miles, you know, that the argument is, oh, well, it only goes around once a day. Can you see the hour hand on a clock moving? And that's moving half the speed, right? Cool, but you're not thinking clearly, right? Yeah. You expand that out, it's moving 1,000 miles an hour. 1,000 miles an hour, even though it's one rotation per day, is 1,000 miles an hour. It doesn't matter. I need to find a big enough area to do this. Here's an experiment. So you get like a rock or a tennis ball or something, and you put it on a string, maybe 20 feet long, and you start spinning it around, and you spin it around where it's maintaining its spin off the ground. I'm holding the string, and as I'm turning, you know, the farther out it goes, the slower I can go to keep it out there. Okay. And now it's centrifugal force is holding it out there just 20 feet away or something. At the same time, I have another one on a string that's only 6 inches long, holding in the same hand. And as I'm turning around, that one barely swings outwards. It's both going around once per the same period, but the farther one is being pulled harder. The inner one is not. It's like the adult merry-go-rounds. You know, the little kids can't sit on the outside one because they can't handle the force. They go on an inside one, going around the same rotational speed. It's the linear speed that matters. It's not the angular speed. I think it's the rotation speed. So we got NASA. Actually, this is the wrong one. He's got his shoes on the wrong feet. He's got his shoes on the wrong feet. All right. I'm trying to find what was your other question as I'm trying to find the thing that I just made. Go ahead.
I got loads, but I just wanted your take on the vapor canopy. This new thing that has come up now with
tell me about it. Do I know about this?
Steve,
Jason Brashears is talking a lot about it. All the ancient cultures, there's been about 4 books written about it. They say there was a time when the waters above, there was a vapor, and instead of where the clouds are, there was a mist or a fog going much higher than the clouds. And this collapsed, which would be called I don't think it's the Great Flood, but the flood of Noah, and this was supposed to be a time where you couldn't see the sun. The skies were dark purple. You know, the ancients talk about this. There wasn't even a moon for a time. And then the brightest lights in the sky were the stars, but they were magnified by this vapor. So they looked a lot bigger. Have you heard anything about this?
No, I don't know anything about it, but you know, Jason Brashears has some very interesting stuff. He says that we live in a simulation. I kind of agree. We live in a physical simulation because this place makes no sense otherwise.
There's a lot of anomalies that just don't make sense.
But you know, he takes some leaps saying that you know, we're in this cycle of 140 years or whatever the number is. Well, you'd have to live through 3 of them to know it's a cycle. So, you know, he's basing his information on a lot of interesting stuff. Again, you know, I don't buy into anything 100%. So if you can ignore the fact that I'm transparent here, check this out. So when you watch it like this, just go look at I forget the name of this video, building height checks. Look at this guy. Does that give you the willies? Does that like make you
I don't like that.
yeah. So this video is called, I think it's called, I Bet You Can't Not Turn Away. Okay. So what is going on here inside your body, right? Your body is going, oh my God, and it's freaking out, like it's freaking out, right? Because it's a self-preservation trick, not trick, a mechanism, right? Then we look at this. Okay. Do you have that same feeling anymore?
Nope.
All right. You have that same feeling anymore? Watch any spacewalk. You never get that feeling.
Yeah.
Right. Because your subconscious knows this is just CGI nonsense. Right.
The Earth's not even spinning there.
I might be a little, who knows? They can't get their spin right. But
go watch any clouds. It should be moving 1,000 miles an hour.
Any spacewalk. Any spacewalk. Look, are you getting that feeling? Your testicles should be in your throat at this point. Okay. Yeah. All right. Nothing. But then you watch those other videos, you're like, whoa, I can't even look. Okay.
Yeah. Do you think this is CGI, or do you think they're up with a fisheye lens, maybe, a little higher than an airplane film?
They're not up there. This is just a high altitude GoPro footage. I mean, you can watch.
That's what I mean. Not the guy. Yeah, I mean the Earth itself. Where do you think they're getting that? Are they making it, or high GoPro?
It could be from an airplane, a drone, or a balloon, right?
Yeah.
But if you took screenshots of the right, look, flat horizon, right, and then as it goes up, it starts bulging. Okay, what the hell's going on?
Yeah.
Look at the amount of curve. That's why they try not to show you too much of it, right? But here's the thing. I don't get it. Can't they do a better job on keeping the curve consistent? I think they should be able to, but maybe they're just stupid, lazy, or they're purposely, saying, hey, we'll show you. Look how tight this is getting. And then as it comes down, it flattens out. Right?
Would have thought
that shows you right there.
All of the millions of dollars that they get every year, they could do a better job than that.
That's my question is, where is the money going?
Yeah.
It doesn't cost that much to make a fake space program. So where's all the cash really going?
Well, NASA doesn't get the money. People say, well, it's going into black projects. It's going into, people, politicians' pockets, who knows? But in reality, the elite that control the money, they don't need money because they can just type ones and zeros and make money. They tell us how much money is being printed. How would you know if they printed twice as much? How would you ever know? You don't know. Yeah. And so they use money to control us. We're on their fiat system, on their fake world. That's how they control us. Those are the number one and two ways that they control us. They have us believing we live on a spinning ball flying through space, so we're insignificant. And then they also have us using their fiat fake money. And until we have the courage to get off their ball and stop using their money, we're going to be slaves.
Absolutely.
Couldn't agree more.
Yeah.
I think part of the whole point of this is a copyright thing. I think because our names are all copywritten, all capital letters, corporation, it's like they own the rights to this fake reality called this place and the calendar, and then, so it's almost like the whole thing is set up for copyright so they can tax you and, own your names and all that. It seems just like that, like we're living in Harry Potter.
Yeah, there's so much deception in this world, but on the other side, there's so much truth to be found. And when you find that truth, you take your power back, and there's nothing, the biggest scam in the world, the biggest scam meme or whatever is the only thing that's true is death and taxes. And I disagree with both of those.
Yeah, true.
Yeah, this is the umbrella satellite receiver that he talked to Nixon with from the moon.
I don't know what umbrella. Nixon had a landline.
Yeah.
That's just ridiculous. They have his shoes. They have Neil Armstrong's shoes in the Museum of Science and Industry in Chicago, where I'm from. And they're the bottom of the boots don't even match the prints on the moon. Like they're the wrong soles.
Right. And the globalists will say, you know, that's because they're they wore boots over them. Whoops. It's the wrong one. Here we go. Here's the new boots that they're using for Artemis. Look, those are just rubber rain boots. Okay.
It's pathetic.
Yeah.
Good vacuum there. That
Yeah.
thing's airtight, baby. Nothing's getting through there.
Yeah.
That's hysterical. But I mean, NASA's just such a joke. What they were up there, they're supposed to be for 3 years in the ISS, and they asked the guy, like, what are you excited about? He said, I can't wait to see my family on Thanksgiving. You're like, what? Are they going to fly them up in a space shuttle or what? Like,
What about when the astronauts are on the moon? Basically, if you read the transcript, they never once said, hey, look at the Earth. They never even mentioned the Earth, right? If we went up there, if anyone went up there, the entire conversation should be, holy crap, look at the fucking Earth. Holy shit, look at the Earth. Oh my God, look at the Earth. Look, there's China, there's Russia, there's, oh my God. Oh, that should have been the whole conversation. And instead of taking pictures of all the impossible number of pictures they took, they should have been looking up at the Earth the whole time.
yeah.
But
Exactly,
they couldn't do that.
There's another thing with that Earthrise picture from the moon landings. When you see the Earth coming up, it's the same size as we see the moon.
Yeah.
But surely
yeah.
Earth is 6 times bigger than the moon, so shouldn't it be 6 times bigger in the sky?
Yeah.
Yeah. It's
But it's not.
It's crazy. You guys have the Artemis, there's so many pictures from Artemis that are just right along there. But you guys saw this. This is, they take off, they slingshot around, they go to the moon, they go around, and then they eject something which sends them back to Earth. But somehow how do they get to Earth, back to Earth in a couple of days? Like, how do they regain the speed that they need to get back to Earth? Right? Oh, gravity. But if you look at this is from NASA. Do you notice anything on here?
That's the flat Earth map.
That's the flat Earth map.
Yeah.
That's the flat Earth map.
They're telling us.
Yeah, they always tell us.
Yeah.
Yeah, it's crazy. That's great. I think that one with the lands is sitting in the UN or something. They have like a flat Earth map with the extra lands outside of it. I think it might be in the UN building. Yeah, it's completely nuts. I mean, just everything we've looked at right now for the last hour and 40, however long this has been going, all of this combined, if that's not enough to make someone go, hang on a second, you know what I mean? I could see if it was one thing, but you've just showed almost 2 hours of impossible to explain things other than we're on this system right here, this flat one.
There's so much. I mean, here's a close-up during the launch of Artemis. Now, all the thrust is supposedly coming out of these things. So I would say these shouldn't be made out of balsa wood or balloon material. They should be pretty strong to lift up millions of pounds of weight. But look at this one. It's overinflated.
Yeah.
What is going on there? Right?
Dave, have you seen that? Have you seen that liftoff where the rocket literally folds in half?
Like it's a balloon itself almost.
Oh yeah. So the on the app, on the web button page, which is the more resources page, scroll down to rockets are balloons and watch those. It's mind blowing when you see it's absolutely mind blowing.
They make sense because, that amateur rocket launch you showed, the one that's just stopped when it hit 70 miles up, rockets take off fast. These things like have giant 4 thrusters and take off in slow motion. They should just shoot straight up into the sky.
Right. And if you time, they have to get to, 20,000 miles an hour or whatever. And the amount of times that the engines are on, they have to increase to like 200 miles an hour every 5 seconds And that's not happening. And if you look at the astronauts in there, they're pushing stuff with canes. If you're accelerating that fast, you're going to pass out, let alone, just sit there and not be nervous about anything, right?
Just the decibels would jellify you anyway. The decibel those rockets go at would Ross did a film on that. I mean,
this is the space shuttle. I call it the space shuttle blimp, right? it's literally it's a helium rocket. It's literally helium, right? This is a helium. That's why it rolls on its back. Now this thing's over 4 million pounds, right? Look at this fence right here. Super hot thrust is going to come out of there. Fence doesn't even budge, right? Makes you think that these people are right there, right? But watch, it's going to go up and then down again. You don't lift 4 million pounds and make it go up and down. So we go up and back down again, right? You don't bounce like that unless you're a bouncy house, okay? Right? Yeah. And one more. So the story on the external tank, it supposedly falls so fast that it deatomizes and burns up and never hits the ground. Does that look like it's about to burn up and never hit the ground? Okay. So it's worse. This thing is falling so fast, it's going to burn up. How are they filming it?
Yeah.
How are they filming it? And wait, and it's worse. The person that's filming it is on the shuttle heading into space. So they're heading 20,000 miles an hour up as this thing is free falling.
Should be getting a lot smaller. But it's not.
In a second, a friggin' second.
Or you should see them zooming. It should be zooming to try to keep up with it. If
it can't. And this is just floating. And on the Rockets Are Balloons link, I have a detailed video where there's a cloaked, if you will, a hidden, some sort of technology aircraft that is following this thing. And it must be some sort of retrieval craft. And it's caught on film.
Following this thing as it's
trying to grab it. Yeah.
Brilliant, man.
Yeah.
Yeah.
Guys, I do got to run. I got to jump on another show. All my stuff can be found at flatearthDave.com. Check out the app. Check out my crash course. Free yourself from the heliocentric matrix. You guys are long free from it. So this is for, even if just one of your listeners, takes it, gets the app or just does the crash course on the website, you will then free yourself. And if we free one mind with this call, that would be fantastic. So hopefully, hopefully anyone that's listening that thinks this is crazy, takes the challenge, and then you'll know.
Great, man. Thank you so much for taking the time to do this with us too.
Yeah. Thanks a lot, Dave. Really appreciate it. Good to
man.
meet you.
Thanks.
Great.
See ya.
An old reel received by mistake. It contains the raw or unedited footage of the crew of Apollo 11, Michael Collins, Edwin Aldrin Jr., and Neil Armstrong, staging part of their mission for nearly an hour in living color, with exceptionally clear behind-the-scenes audio of conversations discussing the techniques used to achieve a disingenuous picture depicting the Earth at a distance, in order to falsely demonstrate their far journey from it and their ability to survive passing through the Van Allen radiation belts. It cannot be misconstrued that this staging was done for some other reason prior to the mission, for the reel itself is slated and dated July 18th, 19th, and 20th, 1969, the very days of the mission when they were said to be approaching and achieving lunar orbit. Not only is the radio conversation between the astronauts and Houston Control audible, there is a secondary, private conversation taking place between the crew and a third confidential party, prompting the astronauts with what to say, when to speak, and how to effectively manipulate the camera to achieve the desired misleading effect. NASA claims that the Houston transmissions were the only ones taking place with the astronauts. Listen now as Houston Control initiates a conversation with the crew, only to find them too preoccupied with the behind-the-scenes trickery to respond. Moments pass and the oversight is picked up on by the clandestine third party, who quickly prompts them with talk. Immediately, Neil Armstrong speaks.
Hello, Apollo 11. Houston, Goldstone says that the TV looks great. Over. Okay, Roger. We're wrapping in on Earth.
Again, the illusion they are attempting to create is the Earth at a distance to demonstrate their far journey from it and their ability to survive passing through the Van Allen radiation belts. Understand, too, that only about 20 seconds of this raw footage was ever broadcast to the public, and these conversations discussing their deception were believed to be private. Until now. Here they discuss that these television transmissions were in fact not broadcast live as everyone believed. They were first screened and edited for playback later.
Roger, Neil. We just wanted a narrative such that we can, when we get to playback, we can sort of correlate what we were seeing. Thank you very much.
Here they discuss the fact that they have turned out the lights and have blocked out sunlight from entering the spacecraft through the other windows, as to not cause any reflected light to fall onto the spacecraft's wall in the foreground.
Okay, very good. Well, we shut out the sun coming in some of the other windows into the spacecraft, so it's looking through the number one window, and there isn't any reflected light.
The reason this was done is so that the truth of the matter would not be revealed. It is this. Though the federal government would have you believe that this is a view of Earth from a distance out of the spacecraft's window as it nears the moon, it is not. What they have ingeniously done is placed the camera at the back of the spacecraft and centered the lens on a circular window in the foreground, outside of which it is completely filled with the Earth in low orbit. The circumference of the window then appears to be the diameter of the Earth at a distance, with the darkened walls of the spacecraft appearing to be the blackness of space around it. That is why they wanted the interior dark and blocked out the sun from entering through the other windows. Here you can see the extruded window, probably 2 inches thick at the bottom. This is because the Earth's shine is coming in at a downward angle. It also causes the Earth to appear to be an irregularly shaped circle, for you are seeing the outside of the window at the bottom and the inside of the window at the top, which together form 2 different sized halves of a circle. Subsequently, this take was never used. As they perfected the shot, a crescent-shaped piece of black material was inset slightly into the window to create the illusion of the Earth's terminator line dividing night and day. It is uncannily convincing. During this segment, intended to be edited and played back later for the worldwide television audience, dated July 18, 1969, Neil Armstrong condemns himself as he states that he is 130,000 miles out, or halfway to the moon, as the NASA flight log also states on this date, when he is in reality in low Earth orbit of a few hundred miles.
Roger, Houston, Apollo 11. Calling in from about 130,000 miles out.
Here, during another segment, also intended to air after review, Neil Armstrong falsely explains to the viewers how the shot is attained by putting the camera's lens to the window's glass, as it would have to be if they were the claimed distance away from the Earth.
We only have one window that has a view of the Earth, and it's filled up with a TV camera.
If the window was completely filled up with a TV camera, as he stated, then an astronaut's arm would not be able to get between the camera and the window, as it obviously does here in this outtake.
South America becomes invisible just off beyond the Terminator or inside the shadow.
You can also notice how the astronaut operating the camera reacted to the mistake by attempting to pan away from it.
Blue gas, see white bands of major cloud formations across the Earth. And
This is a segment that they believed wasn't even being recorded, much less suitable for broadcast, for the lens was being zoomed out and the scene was being changed to that of an interior of the astronauts at work, and apparently the stop button popped back up on the recorder without notice. Here is the diffused work light that they used to see camera controls, but not throw light onto the spacecraft's wall. Here they remove part of the crescent insert. Finally, the iris is opened up and you can see the real location of the camera and the very bright and near Earth out the window. Here is the slate for the 19th of July, and the same shot of trickery on the 19th of July, and then the 20th, and the same misleading shot on the 20th. Later that evening, they were said to be walking on the moon. How can this be when they were in Earth orbit only 9 hours earlier, and the moon is some 3 days' journey away? Furthermore, if they genuinely went to the moon, why would they be faking any part of it? Why this trickery with the window? By faking being halfway to the moon, it becomes apparent that they did so because they could not even go halfway.